Good morning, one and all. This is Dr. Diana. Welcome to session 22 on modern software engineering. We have been dealing with a lot of aspects about agile development, and in agile development, we have looked into unit 4 and 5. We have completed, and we have completed a revision of those two units as well. And in unit 5, it was talking about various development strategies, and in unit 3 we have been identifying some planning methodologies, and unit 3 is what we started with our revision. Unit 3 deals with releasing of your software, and we saw that when a software is under development, you plan for it, and then in iterations you start developing a software. When you start developing your iteration, when the code is always focused on some story. So we have seen that stories form the cornerstone of agile development. So you start with a story, you work on a story, and then you complete the coding of that story. Based on the completion criteria that is given to you, or the done criteria, you evaluate the story and then deliver it to the customer. So this is how agile development works. Now when you start developing your story, the code is said to be the development code, or it is also called as a story under development. And once you complete development, it becomes your production code. A production code is something that the programmer has completed development or coding with. This production code is then given a checklist for which it is tested against. Once it is tested and then proved that it is working fine and it becomes a deliverable to the client, you just add on all the other necessary files to the production code, and then you deploy it on the client's place. That is called as the deployment code. So any phase of code, it goes through 3 phases. The first one is under development or the development code, and then you go into the production code, and then into the deployment code. And releasing means we start from the development, and then you plan for pushing your development code into the production phase. Once you are in your production phase, you push something into your deployment phase. This way of pushing your code from one phase to the other is called as releasing. And we have seen some basic principles which can help us push our code to the next phase in a very short amount of time. And we have seen a checklist of what all to be verified every time we push code from one phase to the other. We have seen what releasing basically means. We will concentrate on the first aspect, which is called as the bug-free release. This becomes a very important aspect in any form of software development. So anytime we talk about software, we always talk about bugs. Software does not come bug-free. And the idea of agile development is to develop a software that is bug-free. So how do we develop a software with no bugs? Is it possible? What is a bug, in fact? A bug is a defect or any behavior of your software that will unpleasantly surprise important stakeholders. So it is some aspect of your software that is not liked by the customer, or it behaves in a way that is unexpected by the programmer himself. So how do we identify such spots? How do we ensure that these bugs are eliminated? Now, in agile development, we see that we have started working on different phases parallelly, or in the sense, a team is working on design where another team is still collecting requirements. One team is planning on deployment while the other team is still in the design phase. So that's how it we incrementally design and develop a software in agile methodology. So there is no particular group which is exclusively dedicated to testing. As long as a developer is developing a code, it is part of the developer and the team's responsibility to test on certain aspects of the code before they push it into deployment. So there is no dedicated testing phase in agile methodologies. So in such a scenario, is a bug-free release possible? If I am the one who is developing and I am the one who is trying to identify whether there is a fault or not, will I be able to exhaustively find out all the bugs and then to rectify it? Is a very challenging question. Now, no bugs is an ideal to strive for, but it is not something your team will necessarily achieve. So your team may not be able to achieve that no bug ideal state. However, when you use XP methodology or extreme programming methodologies, you can achieve dramatically lower bug rates, or very negligible less amount of bugs will be there in your code when you follow the extreme programming methodologies strictly. So how do we achieve these no bugs? When we talk about no bugs, many approaches have been suggested to improving software quality. All of them revolve around finding and removing more defects through traditional testing and inspection. And we have also had some automated tools that can help us through this process. But in agile approach, the main idea is to generate fewer defects, or in other words, I can say, instead of trying to rectify something after you have already fed into the system, you can avoid feeding those bugs into your system as the basic objective or the idea behind agile strategies. This isn't a matter of finding defects earlier, it's a question of not generating them at all. How do we ensure that we do not generate bugs? How can we make sure that during the development process itself, the agile methodologies focus on a no bug generation model? So it is not the coding that ensures the no bug state, but it is the entire development process itself. The process with which we start our coding defines how we develop this software. So in agile methodologies or in extreme programming approach, we are going to use a few strategies or few principles that help us come up with a no bug release. These are very simple principles, but it becomes very complicated when you work in multiple teams parallelly, each of them dealing with a different phase of development. The first principle is to write fewer bugs, which means we use a variety of technical and organizational practices. And all that we try to do during development is to come up with a software that is able to capture the client's organizational process and then to automate it. When we talk about automating a process, rather than trying to code something, it becomes easier to write fewer bugs. And the second aspect is to eliminate bug breeding grounds by refactoring poorly designed code. Whenever we talk about bug breeding, it means that when the software has a lot of technical debt in some of the areas of development, those areas tend to produce a lot of bugs. Or in other words, when I say if I touch that particular part of the code, it might cause a lot of bugs in other areas as well. To avoid this, you need to eliminate such technical debts as you develop. So over a period of 4 or 5 iterations, you should be able to refactor your code and then make it more optimal than how it was earlier. This is where refactoring plays a major role. So once you have refactored your code, you can make sure that they do not breed more bugs on those lines. And the third main principle is to fix bugs quickly. or in other words, we can say that the earlier the bugs get fixed, the less the impact or the cost it induces. So when you write test suits, you need to make sure that you identify the bugs earlier, or you have to adopt a fail fast strategy. In the test suits, it is better that your software fails at the earliest, so that you are able to identify your bugs at the earliest and then to fix them. And when we talk about fixing of bugs, it is radical that most of the bugs may not require an immediate fix up, or the impact of those bugs may be very negligible when compared to the amount of work man hours you put on rectifying them. So you need to find a balance of which one to rectify and which one to continue along with until a few more iterations. And the fourth main principle is to test the process. And when we talk about process identification, we can see that a technical debt arises mostly in areas when the organizational process of the client itself has a flaw. So you might have to do a little bit of research on the process the client actually follows, so that you can rectify the process. When you rectify the process at the client end, it is more likely that your technical debts may be drastically reduced, which in turn will reduce the bug breeding at that particular part of your code. And the last principle is to fix the process. Fixing the process might require a lot of cooperation from the stakeholders and the client, and it may require that you do a lot of research and discussion before you fix your process. Unless the process is fixed, it is impossible to clear off some of the bugs in your development. So it is always good to have a discussion or in the earlier stages of your iterations to fix your process. So if you fix the underlying process, then clearing of technical debts becomes an easy process. Now, the first aspect which we talked about is writing fewer bugs. How do we do it? Is it possible to write fewer bugs, or do we assume that the programmer intentionally writes bugs into the code? It is not so. In that case, you need to take a rigorous and a thoughtful approach to the software development. Now, this test-driven development, which we have seen in our earlier sessions, it is a proven technique for reducing the number of defects, because you always have a testing part in every bit of code that you develop. So in the TDD cycle, we see that when we think of a feature, we immediately think of a test that can cause your feature to fail, and then you develop a code that doesn't fail in that test. So a part of test is always integrated to the development. So by the time you complete your think, the green, red bar, green bar and the refactoring phase, you can be sure that the features that you intended your software should have will not fail, at least in the aspects that you have already tested. Now, this TDD life cycle, it also structures your work into small and easily verifiable steps, and make sure that you verify those steps through the development itself, so that you don't have to spend some dedicated time over the testing phase. Now, in TDD, the next important aspect to be noted is you allow the programmers to work only sensible hours, and then you program all the production code in pairs. When you start with pair programming, it is very likely that the number of bugs that you write into your code reduces. And you can always eliminate coding defects when you do pair programming. And to supplement these practices, we can adopt some good coding standards and then develop a perfect done checklist before you even deploy your code. Now, this done checklist has to be prepared with the idea not just about the features and the behavior that your code should possess, but also about the coding standards of your organization. And make sure every team member in your team is adopting the coding standards perfectly. And the second important ingredient, which is the elimination of bug breeding grounds, is very, very crucial to no bug release. Now, Even in the test driven development, we see that our software can accumulate a lot of technical debt over time. What does this technical debt actually mean? There is some lack in the design, or in the code, or in the testing, or in the non-functional performance of your system. Now this gets accumulated over multiple deliveries and iterations. Whatever we have not completed in our first iteration on the non-functional aspect of a particular part of the code, it becomes very, very critical by the time the same story comes to the iteration 4. So to avoid such a technical debt, we can see that these technical debts, most of them will be in design or in making code defect prone, and it becomes difficult to change as you move in the time scale. It will tend to congregate in specific parts of the system. So one aspect of your code will start magnetically attracting all the other bugs in the code, and any change to that critical portion will reflect in a lot of other places. These are called as technical debts or bug breeding grounds. Although you can dedicate 1 or 2 weeks exclusively for paying off your technical debt, it is always advisable to do some incremental improvements in every iteration. So we have seen that we have introduced some slack time in every iteration to get rid of or to pay off the technical debts. These slack time help us not only to meet our iteration commitments, but they also help in elimination of bug breeding grounds. The third important aspect or the ingredient is to fix the bugs immediately as soon as you discover them. These may not be 100% possible, because programmers know that the longer you wait for the team to fix a bug, it costs more to fix the bug. In addition, unfixed bugs probably indicate there are further deeper problems to the system and to the process or to the design than just the coding aspect. So to fix a bug, you start by writing an automated test that can demonstrate the bug first, and then you can also do a unit test or an integration test, a customer test, depending on what type of defect you have actually identified. Once you have a failing test, and once you have identified the actual cause of the bug, then you fix the bug. If the bug is just the coding aspect of your program, then you might get a green bar immediately after you fix the bug. But if the bug is a result of a design or a process flaw, then it might take you longer to fix what is wrong in your program. Although you may wish to fix everything right away, you need to consider the cost and value of it before you do so. So some of the bugs are expensive to fix, but they have limited impact on the actual code. These may not be worth fixing, and so you identify the impact and the bug actually has on your code, and then you fix accordingly. Not all of the bugs are to be required to be fixed. And don't play the bug blame game, which means don't blame it on other teammate that they have raised the bug. So it's a part of everybody in the team to take ownership of the code that is developed, and then to clear off every time when it is required. Now the fourth ingredient is the process which is being tested. These practices will dramatically cut down the number of bugs in your systems. However, they only prevent bugs that you already expect. Before you can write a test to prevent a problem, you have to realize that the problem can occur. So unless you have a realization, it is impossible to identify the bug and to fix it. So in such a scenario, exploratory testing can help you effectively in finding out unexpected bugs. Think of exploratory testing as a testing your process and not just the code that you have developed. And the last and the main ingredient of your testing and the no bug release is fix your process. This is very, very difficult, I agree. and most often bugs indicate an unknown flaw in the approach itself. So when the number of bugs you generate gets low enough, you can do something usually associated with NASA's space shuttle software, which is called as the root cause analysis and the process improvement on every bug of this. And even if your defect count isn't very low, then you can allow yourself to do some root cause analysis for each of the bugs that you consider as important, or you can randomly pick up one and then start working on the root cause analysis in the further iterations. This will help you identify the basic flaw in your design, or maybe in your approach or the process itself. And when you all these aspects together give us a new dimension of how we can develop a bug-free software. We may not be able to achieve 0 bugs, but we'll be able to achieve a milestone or a very close to the ideal scenario when we start delivering or deploying to the client. So with this, I'll stop for today's session. We will meet in the next session with a lot more on the rest of Unit 3. Thank you, one and all.